Hey guys, and welcome back to my channel. So we're going to continue and finish up with geometric sequences here. So if I take a look at question number 15 here, we have in a geometric sequence, the first term is 5 and each succeeding term is double the previous term. What's the fourth term? So before we do anything, we need to recall what the formula is for a geometric sequence. Now remember, on the Regents exam, they will not give this to you, so you need to know a sub n is equal to a sub 1 r to the n minus 1. That's our formula. Okay? So we know that this is geometric, so that's the formula for a geometric sequence. We know the first term is 5, so there's my a sub 1 is 5. Each succeeding term is double. If everything is being doubled, we know r is going to equal 2, because everything is being doubled. That's that factor. Everything's being multiplied by 2. And we want to know what's the fourth term. When we know the fourth term, that means n is going to equal 4. So let's plug in. We have a sub 4 will equal the first term of 5 times the ratio, whatever it's being multiplied by, that common ratio of 2 to the 4 minus 1. And I'm just going to type that straight in my calculator. And I end up getting 40. All right? And this actually came from a Regents question. Okay, why don't you give number 16 a try? See if you can come up with what the common ratio is for this geometric sequence. So what's the common ratio? What's r equal? Okay, so remember, we find r by taking any term and dividing it by the previous term. So if I take any term, let's say 16, and I divide it by the previous term of negative 8, well, 16 divided by negative 8, that's negative 2. So there's my common ratio. All right, awesome. Let's just keep going. Let's finish up with 17 and 18 here, and we've still got 19 as well. All right, so for question 17, which of the following is the formula for the nth term of this sequence? So we first look at our answer choices, and all of these answer choices are dealing with something that's geometric, right? It follows that formula of a sub n equals a sub 1 r to the n minus 1. All of these answer choices follow that formula, okay? So let's take a look. From our sequence, we know a sub 1 is going to equal 54. We are trying to find the nth term, so we don't know n, so we leave it alone. Do not plug anything in for n. And we know the common ratio, and we can figure out the common ratio by taking any term and dividing it by its previous term. So again, I'm going to take any term, which I chose 6, and I'm dividing it by its previous term of 18 to get r. So I have 6 over 18 simplifies to 1/3, so I know what r is. So I'm just going to plug everything in, guys. Nothing changes with n, that stays as is. I know the first term is 54 times, we have 1/3 to the n minus 1. And that's it. Do not multiply 54 by 1/3. This is wrong. You just leave it as is. Okay, if you guys were to think about PEMDAS, PEMDAS says parentheses first and then the exponents. Does not say to distribute, so this would have been wrong. Okay, so we should be picking here answer choice 4. All right, let's keep going. We have which of the following describes the sequence below? So the only sequences we've ever talked about, guys, are arithmetic and geometric. So immediately you should be ruling out quadratic and cubic. Those are not sequences. The only sequences we've learned are arithmetic and geometric. I am just going to write here again, just as a reminder for ourselves, that for arithmetic sequences, that we follow that formula of a sub n equals a sub 1 plus n minus 1 times d. And for the geometric, again, gotta know these formulas. Arithmetic sequence you don't need to memorize, but geometric you do. That's our a sub n equals a sub 1 r to the n minus 1. Okay, so those are the two different formulas. All right, so let's take a look at what we got here. we're going up by what? How did I get from 2 to 4, 4 to 6, 6 to 8, and 8 to 10? Okay, very good. I'm adding by 2 every time. Every time we're adding by 2. If I'm adding or subtracting by a number, that's an arithmetic sequence. Okay? If I'm multiplying or dividing, that's a geometric sequence. So let's take a look at question 19. All right, let's see what's going on here. I went from 2 to 4, 4 to 8, 8 to 16, and 16 to 32. Again, you should be ruling out this quadratic and cubic. We have never learned about sequences like that. The only two sequences we've talked about are arithmetic and geometric, which we have here and here. Okay? So for this sequence here, how did I go from 2 to 4, 4 to 8, 8 to 16, and 16 to 32? Very good. We're just multiplying by 2 here. Because I'm multiplying, that means we're attached to that geometric sequence. So this is geometric. All right, and let's finish up here with, we got question 20 of just the multiple choice. We'll wrap up the multiple choice. Okay, so we have the first 4 terms of a sequence are as follows. So these were what's given. Which represents the recursive function for this sequence? Okay, and just so you guys know, answer choice 3, this is missing parentheses around the 3. Okay, so if you guys remember, a recursive sequence is when we're talking about, remember we said that previous term. So that was when we were dealing with that a sub n and then the a sub n minus 1, where that a sub n minus 1 represented the previous term. So hopefully we remember that from when we did our arithmetic sequences. Okay, well, let's take a look. We always need to be given the first term, which in every single multiple choice answer we are. We're given a sub 1 is 8. So that doesn't let me rule out anything. Okay, well, let me pay attention to what kind of sequence this is. Is this arithmetic or geometric? Take a second to think about that. Is this arithmetic or geometric? Good, this is geometric. We're multiplying everything by 3. We're multiplying everything by 3. So if I were to take my geometric formula for that geometric sequence, okay, so for my geometric sequence, we had that formula was a sub n equals a sub 1 times r to the n minus 1. But remember, this is dealing with a recursive sequence. Recursive sequence, all it requires us to understand is that we take the previous term and multiply it by this common ratio. So I actually don't even need this. For a recursive sequence, I'll say it again, we take the previous term, which is that a sub n minus 1, and multiply it by the common ratio of 3. The only answer choice that lines up with is answer choice 3. Okay? We took the previous term and we multiplied it by the common ratio. All right, hopefully this was helpful and clarifying. Let's continue to move on. So for question 21, this is actually a good place for you to pause the video and see if you can place where these sequences correctly belong. So pause the video here. Okay, figure out if it's arithmetic, geometric, or neither. It's neither of them. All right, so hopefully you got the same answers as me. I color-coded them. So in blue, you have your arithmetic sequences. So that means it's either being added or subtracted by that constant amount. That's your common difference. For geometric sequences, I drew that in green, meaning that I'm either multiplying or dividing by that constant factor or that common ratio. And then in yellow, I drew in what was neither sequence. It was neither arithmetic nor geometric, meaning there was no pattern whatsoever relating to addition, subtraction, multiplication, or division. All right, so we know that a sequence is arithmetic because there exists a common difference. And remember, when we use that in our function equation, we use that variable d. All right, so I'll just highlight that here. Common difference is the key word. We know something is geometric when there exists a common ratio. All right, key words here, guys. These are things that you will need to know past algebra. Okay, so there exists a common ratio. And then we know something is neither arithmetic and not geometric because there is no common difference and no common ratio. All right? Okay, so let's just move on to some final practice problems, and you guys should be all good to go with geometric sequences, and hopefully this was a little bit of a refresher on your arithmetic sequences as well. So let's take a look here. Let's take a look at question number 1 where it says extra practice. And notice how I highlighted for you all as well that geometric sequence formula that you do need to have memorized. All right, again, so that's for your geometric sequence. Okay, so for question number 1, given the geometric sequence, what's the common ratio? So again, to find that common ratio, we take any term and we divide by the previous term. So I'm going to take any term, let's say 20, and I'll divide it by 10. Well, 20 over 10 is 2. So there's your common ratio. We next need to come up with that explicit formula for the nth term of the sequence. So remember, this is our original formula. And now we're going to plug in and leave n alone. Do not replace n with anything. So first things first, of things we can replace, we know a sub 1 is equal to 5. That's the first term of our sequence. We know r is that common ratio, which we said before was equal to 2. So I have everything we need. We can fill this in, that a sub n is equal to 5 times 2 to the n minus 1. That's your explicit formula for this sequence. Okay, now part C says, using the equation from part B, find the 11th term. So now I want to find the 11th term. Well, remember, n is now going to equal 11. So I'm just going to plug into my formula here. I have a sub 11 equals 5 times 2 to the 11 minus 1. Type that into my calculator, and I end up getting 5,120. So there's my a sub 11, plugging in to this formula here. Okay, let's just keep moving along here. Question 2. Find the first 3 terms of the sequence defined below, where n represents the position term in the sequence, starting with n equals 1. All right, so we want to find the first 3 terms. So let's find the first 3 terms, starting with n equals 1. So let's plug in for a sub 1, where n is equal to 1 here. So I have 4 times 3 to the first. If I just put that in my calculator, guys, I'll have a sub 1 is equal to 12. All right, let's keep going. I want the first 3 terms. So I took care of a sub 1. Next, I want a sub 2. And then lastly, I'll get a sub 3. Those will be the first 3 terms. Okay, so for a sub 2, we'll have 4 times 3 to the second. Plug that in my calculator, and I get a sub 2 equals 36. Last one here, now I want a sub 3 because I want that third term. So I'll have a sub 3 equals 4 times 3 to the third. Again, just plugging that in my calc, and I get a sub 3 is equal to 108. So I'm just going to write out the first 3 terms of this sequence here. And I want you guys to think, what kind of sequence is this? Would this be arithmetic? Why not? Why would this not be arithmetic? Very good. There's no common difference here. I am not adding by the same amount here each time, so it can't be arithmetic. Well, if it's not arithmetic, is it geometric? How do I get from 12 to 36 and then 36 to 108? Very good. You're just multiplying each time by 3. Multiply by 3 here and multiply by 3 here. This is geometric because there is a common ratio. And in fact, that common ratio, as we just said, ended up being 3. Awesome. Very good. Again, guys, in order for something to be geometric, got to have that common ratio. In order to be arithmetic, got to have that common difference. All right, let's try to wrap it up here. We've only got 3 and 4 left to go, and we are done. So question 3 says, find R in the geometric sequence. We know it's geometric. Well, for R in the geometric sequence, remember we said take any term and divide it by the previous term. So let's take any term and divide it by the previous term. So I'll take that 1024 and divide it by the 4096. Put that in my calculator and I get 1/4 is my common ratio for this geometric sequence. All right, and lastly, guys, here we go. Question number 4. Find the 15th term in this sequence. Now it doesn't specify whether it's arithmetic or geometric. We got to think. Okay, so first things first. If I want the 15th term, we know n is going to equal 15. I know a sub 1 is 5. That's the first term. Now we got to think, is this arithmetic or geometric? Well, let's see. We're going from 5 to -10, -10 to 20, 20 to -40, and then -40 to 80. I don't think I'm adding or subtracting by the same amount each time. Because let's look. To go from 20 to -40, I would have had to subtract by 60. And then to go from -40 to 100, to go from -40 to 80, I would have had to add by 120. So this is not arithmetic. That means this has to be geometric. So let me write down my formula again for a geometric sequence. We know that formula is a sub n equals a sub 1 times r to the n minus 1. We know this has to be geometric. So if I know this has to be geometric, I'm going to follow my formula here for r, where I'm going to take any term, so let's take that -40, and I'm going to divide it by the previous term. And we get -2. So that's what r equals. So now I'm just going to plug in everything I know. I'll have a sub 15 equals a sub 1, which is 5, times that common ratio of -2 to the 15 minus 1. And guys, I'm putting that straight into the calculator. Please don't do it by hand. And I get a sub 15 ends up being 81,920. All right, guys, so that's actually it. That's all I have for us today. That is everything I need to make sure you are comfortable with and understand in terms of arithmetic sequences and geometric sequences. All right, remember I'm available on Zoom to answer any of your questions as well as remind, email, etc. All right, guys, have a good day.